Let's look at the node formats for a single linked list and a double linked list. So this is the node format for a single linked list. If you go through the previous videos, you will find that I've explained the theoretical portions on single linked list as well as double linked list. Now the node format for a single linked list is, it will have a single data part and a single link part. The node format for a doubly linked list is, it will have a single data part, but it will have two link parts. It will have a right link and it will have a left link. This is the distinguishing feature between a single linked list and a doubly linked list. A single linked list will have exactly one link part. As a result, you can traverse the list only from left to right. A doubly linked list will have two link parts. That's why it's called a doubly linked list, right? Double. So double is for two links. So a doubly linked list will enable you to traverse a linked list from left to right as well as from right to left. Now the question is, how can you represent a node, right? So without nodes, you will not be able to create linked lists, that's for sure. Now the question is, how do you create nodes, right? The first thing that you need to ask yourself is, can I use my built-in data types? What are the built-in data types available in C? The built-in data types available in C are int, char, float, double, and void. Now using any of these data types by itself, can I create a node? Pause the video, think about it for a moment, and then come back, okay? So I hope you have thought about it. Now the answer is no. Using the built-in data types, we cannot create a node for a single linked list or for a doubly linked list. So what is the solution? The solution is, you have to come up with a data type of your own which will help you to represent nodes. Okay, since using the built-in data types, I am not able to create any of the node formats shown here. I need to come up with a data type of my own. Now, how do I come up with a data type of my own in C programming? I use structures. So what I need to do is, I need to define a structure for the node format of a single linked list. I also need to define a structure for the node format of a doubly linked list according to my application. So if I have been given a program on single linked list, I need to first define the node format. If I have been given a program on doubly linked list, then I first need to define the node format for a doubly linked list. Only then can I go on to create a node. Okay, so remember the steps. The first step is to create the format, right? To define the format. Now for defining the format, what you need is a data type. Unfortunately, built-in data types in C do not support such node creation. So we have to come up with data types of our own. The data types of our own that we create in C programming is using structures. So what I need to do is, I need to create a structure to define the node format for a single linked list. Now after I'm done with defining a structure for the node format, I need to create an actual node. Remember, merely creating the structure will not allocate any memory. Only if I create a node, right? Only if I allocate some memory, then only I'll be able to create a node. Only if I allocate some amount of memory will I be able to actually physically allocate a block of memory and call it a node. Okay, so let's see step one. How can we define a data type? So we are defining a data type to represent this node format for a single linked list. So how do I do that? I write struct, of course. Then I give the name of the structure. So you can come up with any name. I'll simply use node. I'll use node. And now I can see that this node format, it has two parts. It has a data part and it has a link part. Now the thing is, the information that I want to store in my linked list can be of various types. Let's say I want to store the names of all the students in my class in a linked list. Then this data part will be of type string. If I want to store the heights of all students in my class, then the data part of the node will be of type float. Let's say I want to store the marks of a particular subject of all students in my class, then the data part will be of type int. So in this way, depending on your application, the type of the data part is decided. So here I want to create the node format for a linked list to store a series of integers. So the type of this data part will be int. So I'll write int data, right? Now what about the link part? Remember, in the link part of a node, what we will store is an address. Now this address will be the address of the next node in my list. A linked list will obviously be made up of a number of nodes. Now the current node on which I am pointing will be storing the address of the next node, with one exception, of course. If it happens to be the last node to which I am currently pointing, then it will store a null value in its link part. But for all other nodes, which are my intermediate nodes, they will always contain the address of the next node in the list. So what kind of variables are able to hold addresses? We know that variables of type pointer are able to hold addresses. So the type of link will be a pointer type. Now the question is, what will be the type of this pointer? Will it be a pointer to integer? Will it be a pointer to character? Will it be a pointer to float? What will it be a pointer to? See, it will be a pointer to a variable. It will be a pointer to a variable which is able to hold a node address. Think about it. See, let me just write the line here. So I'll say struct node star link. Now see, if you look at, let's say I have a small single linked list. Okay, so I have this single linked list. It's storing 3, it's storing 7. The address of this block of memory is 100. The address of this block is 200. So if these two nodes have to be linked, then the link part of this node should contain 200, and since this is the last node, the link part will contain null. And of course, the first node is always pointed to by a special pointer called head. So head will always store the address of the first node. Now see, now this is the link part, right? This is the link part. Now what is the link part holding? The link part is holding 200. What is 200? 200 is the address of this node. That means the link part of any node will always hold the address of the next node. Now what is this node? What is the type of this node? What is the type of this node? Just now we saw that every node is defined using this structure. So the type of this node is struct node. Just pause the video for a moment and think about it. I'll repeat. I'll give you a brief, let's say a brief recap of what I just said. See, what I'm saying is I have a linked list. I have this small linked list. It has exactly two nodes. The first node contains a value of 3 and the second node contains a value of 7. Since the second node also happens to be the last node in my list, its link part contains null. Now this node, the link part of this node contains 200, which is the address of the next node. If I have to link two nodes, then the link part of this node should contain the address of this node. So that is clear. Now the question is, what should be the type of link? What should be the type, the data type of link? See, link has to be a pointer. We all agreed on that because it is holding addresses and we know that only pointers can hold addresses. So it will definitely be a pointer. But the question is, what is the type of pointer? See, since link has to store the address of a node, since the link part is storing the address of a node, the type of link should be same as the type of this node. And since the type of this node is defined by this structure, struct node, the type of link will also be struct node star. So I hope this is understood. Even then, if you have any doubts, what you can do is you can rewind this video and play it 2 or 3 times. But even then, if you are unable to understand, you can definitely comment in the section below. I'll get back to you. So this is how you define a structure for creating the node format of a single linked list. Now, what about this node format? What about this one? Let's see. So this was the structure for the node format of a single linked list. Now, what about the structure for the node format of a doubly linked list? So let's see. So I'll call this structure node as well. Or let's just distinguish this, okay? Oh no, let it be, okay? I think you can do that. You'll rarely require a program where you'll be defining two structures, one for singly linked list and doubly linked list. So that I don't think will be a problem. Now see, look at this. Look at the node format for a doubly linked list. It has a link part. In fact, it has two link parts and it has a data part. So just like we saw for this structure, we decided upon the type of link. Here also the type of link will be the same because link will again hold the address of the next node. So the type of link will always have to be the type of the node, and the type of the node is defined by struct node, just like it is done here. So I'll write struct node star L link, and then the data part. Again, let's say I'm holding or I'm creating a list of integers. So I write in data, and then I write struct node star R link, and then I close off my structure. Okay. So this is how you can define the node formats for your linked lists. Okay. So I hope this helps. If you have any doubts, please feel free to comment. Thank you.